Okay, going over the homework answers from yesterday. First one is draw arrows to show the direction that current moves. Now remember, since current is negatively charged electrons moving, it goes from negative to positive. So you just kind of draw a little arrow here. All of the lines can get one going from negative, so away from the negative, and all of these away, 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 and positive is always towards. There's probably a joke about always moving towards positive things here. But anyway, we got two positives over here, so repulsive, but really the main idea is that, remember, we're always moving towards positives here. So in all of these lines, the arrow should be pointing towards the positive. Notice how in the negative to the positive one on the left here, you get lines moving away and towards. You kind of get this bending towards one another. But in the positives, you get this repulsion, or these lines bending away from one another. So even though the current would always be moving towards that positive, we're good to go there. So here, draw magnetic field lines, the geographic north. So this is geographic north. This is your geographic south. But remember, in this, the magnetic north is different than the magnetic or geographic north. And our lines always go from north, negative, to south, positive. Okay, so this one's kind of a complex answer. We're remembering here that the geographic south is your magnetic north, and that the magnetic south is our geographic north as well. They're opposites. Number 3, really what we got here is different field lines. You have to say, okay, which way are they flowing? Put the north and south for each of these magnets here. So I'm going to start with this one because it's simple. We get the north going towards the south. So anytime an arrow is pointing towards it, that is our south pole. So here I got south, here I got south. That means on the opposite side of each of these, they're north. That's because the arrows are going towards. Here, arrows are going away. That tells me that's north, and that's south, and that's south. And then here we got going from negative to positive, which tells me then the opposite sides of my magnets. Okay, so that's magnetism. Strongly recommend you do the practice questions in the Thursday folder before the quiz on Friday. Thursday, your other option is just watch a short video about what magnetism is used for in everyday life. Here we got some review problems. The answers are here. So 3 subatomic particles. There's protons, neutrons, and electrons. Electrons move, protons and neutrons do not. Net charge of 0, meaning if I have 10 positive, I have 10 negative. If I have more negative than positive, my net charge is overall negative. To get positive charges, the only way I can get there is to lose negative. Like charges repel and opposite charges attract. Electrons and protons have a charge of 1. Objects that allow charges to move are called conductors. I always go from negative to positive. Metals are great conductor examples. Insulators would be like plastics or rubber are good examples there. Positive charge always has going in, negative is out. And that's what we have here. So this type of stuff is what you'll see on your quiz on Friday, whether it's visually or with words. The ideas are there. All right, let me know if you have questions. Make sure you answer those 2 other questions at the end here. Just checking in how you feel about magnetism. All right, bye.